Okay, thank goodness. Something new. We're at equivalence point. Equivalence point means for this particular problem, we've added 100 milliliters of NaOH, again for our graph. We know that because they're the exact same molarities up here, so at the same volume, they'll have the same number of moles. So in this problem, I am going to go ahead and start with the ice table. What I've done here is I've added 0.050 moles of my OH ion to 0.050 moles of my acid. And so I've had a complete reaction. They both are going to react away, and we're going to make water plus our NO2. We're not going to start out with any of him, because again, we're going backwards in time and pretending like we added all 100 milliliters at one instant. So all of this guy is going to react with all of him, because that OH is going to continue to pull H's off until there's no HNO2 left. Water's not going to matter, and we're going to add 0.05. Well, I shouldn't say water doesn't matter. It doesn't matter in our calculation. He actually has a huge role coming up. But I'm going to have 0.050 moles of NO2. So I have none of him, and 0.050 moles of this guy. Now remember, that 0.050 moles is in a particular volume, and I'm going to go ahead and do this now. Again, I added 100 milliliters of nitrous acid to 100 milliliters of NaOH. So this is per 0.200 liters, and that's moles. So my molarity here, that's going to give me a molarity, and that's going to be useful in the next part of our problem. I didn't have to calculate the molarity right now. I could have waited, but I'm looking ahead and realizing, ooh, I have a base hydrolyzation problem here, because now all I have in this solution is water and the nitrite ion. Well, they're going to go ahead and set up their own equilibrium. They're not just going to sit around and stare at each other. We're going to get a salt hydrolysis equilibrium, and you always end up with salt hydrolysis at the equivalence point. Now, to be perfectly honest with you, salt hydrolysis is happening during the entire titration, because again, we're pretending we're looking at two snapshots in time. But it's so insignificant compared to the rest of them that it won't affect the pH. The thing is, at equivalence, there's no more acid or no more base left, so it's the only thing you have to go on. So that NO2 is going to react with water to make an HNO2 plus an OH ion. Now this OH ion being created here is quite important, because it lets me know I need to know this guy's Kb. And I can look him up on my chart, or I can find him by doing Kw divided by Ka. Kb would equal Kw over Ka. Kw is a constant. We're doing every problem at 25 degrees, so we assume we're at 25 degrees. And I can solve that. This would be 2 point, whoops, we'll not do any of that. Why is that line there? All right, we're back on track. Maybe we're back on track. 2.2 times 10. My wife's laughing at me right now as I'm sitting at the kitchen table and doing this, sounding like a fool. 2.2 times 10 to the minus 11 is the Kb value for the nitrite ion. So now I can set up my ice table. I can say, I start with my molarity of him, which at this point is 0.05 moles divided by 0.2 liters. That is 0.25 molar. I don't have any of him and any of him. Look, they're all gone. None of them left in solution. So some of him is going to react, and he's going to make some of these guys. So I'm going to end up with 0.25 minus x. I'm kind of running out of room. X and x. I'm going to cram everything in down here at the bottom. So then I know that I can set up my Kb expression. 2.2 times 10 to the minus 11 equals x squared over 0.25. 0.25 is a It's gigantic number compared to 2.2 times 10 to the minus 11. Huge compared to it, so that x right there is not going to make much of a difference. The difference here is this time my x value is my OH ion. So when I solve for x, it's going to equal my OH minus ion. And when I did that earlier, I got an x value of 2.4 times 10 to the minus 6. And I actually did my calculation with 2.36 times 10 to the minus 6, so this pH might be a little bit off from what you calculate when you do that. But of course, I'd need to take the negative log of that. That'd give me the POH. I'm running out of room, so I'm not going to do that. But the pH from him should be somewhere in the ballpark of 8.37. Here's where we saw our big spike, because now we have a basic solution. It's a basic salt plus water. So it's basic. We had our big spike in our graph at 100 milliliters of NaOH.